We are here for studying the second experiment, that is determination of elevation of inaccessible object by trigonometrical leveling. This particular set of experiment is used to find the height of any building which is very high and far away from the instrument point, maybe because of obstacles or whatever may be the reason. Usually this particular set of experiment is used for finding the height of the hill as well as high towers or a high rise building or a chimneys. Aim of the experiment: finding out of elevation of high object by trigonometrical leveling. Here we are using a trigonometrical concept. As you can see, there are the formulas. Here we are using a trigonometrical base to find out the distance. Here we are using two angles. As you can see, the total alpha 1 and alpha 2. That is, please look at this particular figure. In this particular figure, there are two instruments are used. There are 1 second theodolite of two instruments, so we get a better accuracy. Say station point R and station point P both are at same level and parallel to the ground level. In this figure, it is self-explanatory. You can see here from station point R, we are taking an angle of alpha 2 to the highest point of the object. And then next, from station point P, we are taking a alpha 1 angle at the same point. But at the same time, we need to take care that S is the backside at the benchmark. As this benchmark is required because this height is going to consider with the benchmark value. Here, there are two angles. This is the mirror, actual object is Q and this is Q dash till the elevation or a height of the instrument. You can see there is a height of instrument that has to be measured through the value of benchmark at S. Then we need to find the height of the object H. That H value is, we can find out with the help of this particular equation. First, we need to find out the D value. As D value is inaccessible, it may be total base of the hill or it may be any obstacle. Then how to find the D value, that is capital D. D is the distance between first instrument point, that is point P till Q point, that cannot be accessible. That's why we are using a D formula with the trigonometrical functions. That is D is equals to B into tan alpha divided by tan alpha 1 minus tan alpha 2 to find the D value. Then H is the height of the hilly object, that is H small h. Small h can be found with the help of this particular formula. B is the distance between R and P into tan alpha 1, that is angle of R instrument, into tan alpha 2, that is the angle of P instrument, divided by tan alpha 1 minus tan alpha 2. With this equation, we can find out the height of the object. Then actual in terms of RL, that is reduced level, RL is RL of the Qth point. Means if you want to find this Qth point RL values, then RL of the benchmark, that is benchmark at this particular point, plus S, benchmark is this ground level, plus S will be added, that is the height of the instrument, and H is added, H value is this, then we'll get the RL means reduced level of this particular peak point of the object. This is how we are going to perform the inaccessible object. Finding the height of the RL of the peak of that particular building or any object by using two instruments of 1 second theodolite. Here we are using two instruments. We set both the instrument. From both the instrument, we took a S value, that is S means staff reading, and we labeled both the instrument at same staff reading. So staff reading is around 1.3 meters, 1.365 meters. So that is the recorded, that staff reading is taken from that particular point. Now here we already labeled the equipments, both the equipments, and leveling is done. Along with the leveling, we are finding the inaccessible. What is inaccessible? If you see this in between, there are some obstacles, we directly can't move the objects here. So we are considering that particular point, corner of that particular building. So we are going to consider that particular corner and top of the arch. So I am going to take the recording with the face left reading. Accordingly, similarly, we are considering the face right reading also. First we will take the face left reading. I already marked it. Now I will unclamp the vertical telescope movement and I am trying to see the top of the building, that is 73 degrees, 2 minutes 4 seconds. That is our value. We have secorded with the help of this instrument and we find it the elevated angle, and as well as we have another equipments that is here. It is already set up with the in line with this particular first instrument, that is say P value, P instrument, and this instrument is known as R, and that station point is S. S value is already noted from both the side and both are leveled and set. So we will directly take a second reading of a face left through this R instrument station point. Now we will directly read the peak of that particular building. That building is same and we are reading both the readings from same building only. So now we will unclamp telescope movement, vertical movement. So we will see the reading for the top of that building, same building which is measured the angle from instrument point P. Now we are measuring the point R. I will clamp it and we will see the reading. Reading is 81 degrees, 42 minutes, 3 seconds. With the help of both the instruments, we are observing the same point and both the instruments are in same line and the height of both the instruments are same. So whatever angle we got it from the face left, accordingly we are recording the 2 more set of reading through the face left as well as 3 more set of reading through the face right, and mean of the both face left and face right will decides the height of that particular building which is inaccessible. See the observation table for the inaccessible object by trigonometrical leveling. Here we have 2 instrument station points which are in same line, which are far apart but both are in a same line of collimation, that is 6.12 meters apart. The instrument height of both the instruments are 1.365 meters. In point P we have taken the reading for face left, face right, as well as for point R we have taken the reading for face left and face right. Accordingly readings are for face left 73 degree 2 minutes 4 seconds and face right is 73 degree 2 minutes 3 seconds. The mean is taken of both, and for point R values are 81 degrees 42 minutes and 3 seconds and face right is 81 degrees 42 minutes and 4 seconds, and mean of both the values of point P and point R calculated, and the mean of both average vertical angle is 77 degree 22 minutes 3.555 seconds. This is your average vertical angle, but in this experiment further we need to find the D value, as we know the B and S. This is B, this is S. We need to find capital D, that is inaccessible distance, and RL of the point peak point of the object. So we will see to it further. We are gathered here for finding the actual distance capital D, H and RL of that peak point by using trigonometric leveling. These are the formulas. D formula is B into tan alpha 1 divided by tan alpha 1 minus tan alpha 2. That values are substituted and that respective values are 0.893. This is capital D, and small h, that is height of that particular object, is calculated by B into tan alpha 1 into tan alpha 2 whole divided by tan alpha 1 minus tan alpha 2. The values are substituted and the height of the object will be 38.44 above the instrument height. Then RL of qth point means peak of the elevated object is given by RL of benchmark, where we kept the staff, plus S, we arbitrarily assume that 500 value, we do not know exact, so we assumed it as a 500, and the S, that is staff reading of both the instrument is 1.365, and H just we have calculated. Then total RL of the benchmark of the qth point is 539.81 meter. This is your final result, that is benchmark of qth point is 539.81. You can tabulate the result, this one. This is how we worked out the finding the height of inaccessible object by trigonometrical leveling.